Hello, and welcome back to another math lesson with Matthew. Today we will be covering the law of sines. So in the first problem here, we have been given two angle measures and one side measure. So we know that both of these angles are less than 90 degrees, meaning that there must be an obtuse angle within there. And so we add them together and subtract them from 180 degrees to get 138 degrees as angle B, which is going to be greater than 90, and thus we know that there's an obtuse triangle, and we must have one triangle answer, because we already know for sure two angle measures. Then we can use the law of sines to find both side B and A, and this just goes off the pattern of C over sine C equals the unknown B over sine B. And so we can cancel out sine B on this side to give us the unknown B all alone, and multiply sine B on this side as well to balance the equation. And so doing the math, we get B equals 29 kilometers, and repeating the process for A, we get A side A equals 11.95 kilometers. Moving on to our second problem, we are given one angle measure and two side measures. And so we use the known angle measure, and that is less than 90 degrees. Therefore, this must be an acute triangle. And so to figure out how many solutions we are going to have, we are going to compare the relationship of both sides and the known angle. And so plugging this in, we're going to have side A compared to side C, 40, times the sine of A, which is 67, and that this 40 times sine 67 will equal 36.82, and that is going to be less than 38, or rather, side A is going to be greater than the multiplication of sine A and side C. Therefore, we're going to have two solutions. Now for triangle number one, we can use the law of sines to again find the angle of C, or at least this first triangle's angle of C, and plugging in all of the numbers and information, we are going to get a ratio, which we can then plug into the inverse sine of C to get the proper degree angle, which would be 75.69 degrees. So for this first triangle, we can find the sum of 75.69 plus the angle that we already know and subtract that sum from 180 degrees to find the missing angle B, which is 37.31 degrees, and thus B will be that. And to find side B, we can again use a law of sines and use that to find that side B will be 25.02 meters. However, we know that this triangle has two solutions, and thus we're going to need to solve for two triangles. So to find the other way that the triangle arm could swing, we can thus subtract our original angle C to find the other angle C in this triangle. And so we can subtract the original angle C from 180 to find 104.31 degrees, which is our second angle C. To find the second angle B, we can use a little trick because we know that second angle C is 104.31 degrees, and we also have our given and known 67 degrees, so we can find that the original angle C measure subtract by the given angle measure will give us 8.69 degrees, and that will be the second angle B. Then finally, to find the second side B, we can just use the law of sines again to find that side B is 6.23 meters. Now finally, on to the third problem, and we are again given one angle and two sides. Now this angle is greater than 90 degrees, and therefore this triangle will be obtuse. So when finding the number of solutions for an obtuse triangle, we compare the two sides given directly. And so since they're the same and equal, there will be no solution, as it is impossible to have a triangle with an obtuse triangle with two equal sides, such as this, when the corresponding angle to one of the equal sides is greater than 90 degrees. Thank you very much for watching, and have a great day.